Hello students, good morning. How do you do? In the last class up to importance of design load we have reached. So today we will see importance of design load. The repeated application of any loads of magnitude less than design number excessively load would cause lower stress ratios. Hence, there will be no structural deterioration of the pavement due to these loads. The design wheel load should be carefully decided, taking into account the wheel load distribution studies and the expected number of repetition of loads of different magnitudes during the design life of the pavement, because vehicles will be transferring their loads whenever they come to that particular point on the pavement. It is repeatedly moving on traffic stream, therefore the load application should be considered as repeated. It is suggested that the axle load study should be conducted on heavy vehicles in order to arrive at the design axle load. It is necessary also to estimate the possible movement of overloaded vehicles with loads exceeding the axle load or wheel load. Distribution studies are carried out on the selected heavy vehicles that actually moving on the existing roads. It is also desirable to note that the wheelbase or the spacing between the axles of the heavy commercial vehicles HCV. The objectives of the study are to arrive at the design load, to assess the effect of repeated application of stresses due to loads that are heavier than the selected design load, which cause stress ratios exceeding 0.44 and the number of repetitions of such heavier loads expected during the design life. These data are necessary at the design stage for the fatigue analysis. How to determine the design load? First of all, complete the measurement of axle or wheel loads on the selected samples of heavy vehicles with single, tandem axle, multiple axles at the identified locations. Axle load distribution table is prepared by grouping the loads at convenient load intervals or ranges. The average of each load group is taken as the magnitude of the applied load and the expected number of repetitions of the vehicles of each range during the design life is estimated. This is very important. Axle load distribution with respect to different wheels assembly, say single, tandem, multiple. A table is to be prepared and grouping of loads at convenient load intervals or ranges are to be decided, and then based on these average, each load group is taken as the magnitude of the applied load and the expected number of repetitions of vehicles of each range during the design life is estimated. The total number of axle loads of each interval noted during project preparation studies are noted as the initial traffic. Considering the different vehicle classes, their growth rate, construction period, and design life of the cement concrete pavement, the total number of repetition of loads of each group load during the design life of the pavement is estimated. Based on the raw data, the cumulative frequency distribution table or diagram representing load values and the total number of repetitions during the design life is also prepared. From this table or diagram, 98th percentile load, which will be expected only by 2%, may be taken as the design load. It also desirable to consider a load safety factor of about 1.2 in order to account for the possibility of further overloading of the heavy vehicles. Daily variation in the temperature. The daily variation in temperature causes difference in temperature between the top and bottom of the CC pavement slab. This results in warping of slab and development of flexural stresses. You can see here. This is top when it is hot, bottom during midday, it is cool. In the midnight, it is reverse. Bottom will be at high temperature. Top of the pavement will be of lower temperature, that is cooler. That's why the bend of the pavement will be in this way. Here the bend of the pavement will be in this way. This is known as warping. This is also known as warping. Okay. See, the picture clearly shows how they warp. Temperature during night time. So this is warping daytime, this is midnight warping. You can see all these temperature differences as I have already shown with the rough figure. Okay, during the two short durations within 24 hours, the temperatures at top and bottom of the slabs are equal. No warping will take place. This stage of the cement concrete pavement is called as no warping condition of the pavement. Different types of stresses developed in CC pavements. The major types of stresses in CC pavements consist of wheel load stresses caused by heavy wheel loads, warping stresses caused by temperature differential between the top and the bottom of the pavement. It is possible to determine the stresses developed due to the wheel loads, warping and contraction of CC slab, and not possible to estimate. It may not be possible to estimate the magnitude of stresses as a result of volumetric changes in subgrade. Westergaard gave theoretical formulae to determine the stresses caused due to wheel load applying on the rigid pavements. For this, he carried out the following assumptions on rigid pavements. Cement concrete slab is homogeneous. This is first assumption. It is thin plastic plate. The subgrade reaction being vertical and proportional to the deflection. Westergaard's equations for stresses due to wheel load applied at the three critical locations, that is interior, edge and corner. Interior, edge and corner. Load stresses. Just I will zoom this. So these are the theoretical formulae given by Westergaard for evaluating the wheel load stresses. SI, interior loading stress, 0.316 P divided by H squared, whole multiplied by 4 log B, base 10, 1.069. Edge, due to edge loading, stress SE is equal to 0.572 P divided by H squared, 4 log base 10 B plus 0.359. Corner loading stress 3P by H squared whole multiplied by 1 minus A root 2 by L 0.6. So here it is taken as L, radius of the relative stiffness. Here also it is L, radius of the relative stiffness. Here also L. A is nothing but the area, radius of the loaded plate. Okay. H is slab thickness, P is wheel load in kg, A is radius of wheel load distribution, I have already said. L is radius of relative stiffness, I have already told. B is the radius of resisting section. These are all another formula given by different authors. So what is L? Radius of relative stiffness. Westergaard defined the radius of relative stiffness, and which is expressed by the equation L is equal to EH cube divided by 12K into 1 minus mu squared whole to the power of 1 by 4. Where L is radius of relative stiffness in centimeter, H is the slab thickness in centimeter, mu is the Poisson's ratio for concrete, it is usually assumed as 0.15. E is the modulus of elasticity of cement concrete in kg per centimeter squared. K is the modulus of subgrade reaction in kg per centimeter squared per centimeter. Equivalent radius of the resisting section. According to Westergaard, the equivalent radius of resisting section is approximated in terms of radius of the load distribution and the slab thickness. Radius of the load distribution is A and thickness is H. B is equal to, this is nothing but equivalent radius of resisting section B in centimeter is equal to 1.6 A squared under the root H squared minus 0.675 H, where B is equivalent radius of the resisting section in centimeter when A is less than 1.724 H. A is equal to radius of wheel load distribution. H is equal to slab thickness in centimeter. When A is greater than this, B is equal to A. That is important. When A is greater than 1.724 times the thickness, then B is equal to A. That means radius of the resisting section B is equal to radius of the loaded distribution area. Okay. Whereas if A is less than 1.724 H, then you have to use this formula to find out the equivalent radius of the resisting section. Is it clear? Temperature stresses are classified into warping stresses and frictional stresses. Warping stresses due to temperature differential between the top and bottom of the pavement as a result of daily variation in temperature at the location, and frictional stresses are due to overall increase or decrease in temperature of the pavement slab as a result of seasonal variation in temperature at the location. Warping stress can be calculated, which are developed by Westergaard. Warping stress at interior is given by EET, capital E, small e, T divided by 2 whole multiplied by Cx plus mu Cy divided by 1 minus mu squared, where mu is the Poisson's ratio of concrete. Cx and Cy are the coefficients taken in x direction and normal to the x direction, that is y direction of the slab. Suppose if this is the slab, suppose if I consider this as the x direction, perpendicular to this is y direction. Warping stress at the edge is similarly can be calculated by Cx EET by 2 or Cy EET by 2, whichever is higher. Warping stress at corner is given by EET by 3 into 1 minus mu whole to the whole multiplied by under the root A by L. Under the root A by L. This L should come inside, that's all. 3 into 1 minus mu EET. What is E? Young's modulus. What is small e? What is small e? Coefficient of expansion per degree centigrade. Thermal coefficient of expansion per degree centigrade. Okay? Everything, whatever I have told. So, Cx, Lx by L. Cy, Ly by L. Suppose this is L. This is Lx. And this is Ly. Okay. So Lx by L, where L is the radius of the relative stiffness. L is, in both the case, radius of relative stiffness. That is given by H cube divided by 12k into 1 minus mu squared. Whole to the power of 1 by 4. Okay. Frictional stresses SF is equal to W into LF 2 into 10 to the power of 4. This is constant is used to convert this into same unit, where B is the slab width, L C is the spacing between the traction joint, F is the coefficient of friction. That value is taken as 1.5. F is equal to 1.5. Design of rigid pavement. Design of rigid pavement. How to design? The design wheel load is first of all decided are relevant axial load studies and analysis based on that. Based on the locality where the pavement is to be constructed, the temperature differentials for pavement thicknesses are estimated. Third step is The supporting layers of the rigid pavement such as subgrade, subbase layer or base course layers are decided and the subgrade modulus is either determined or estimated. Fourth step is the spacing between the longitudinal joints to be provided during the initial period of curing. A trial thickness of pavement is first assumed. The load and warping stress values at pavement edges are determined using the appropriate stress equations. The total value of stress exceeds the permissible limit. The trial is repeated assuming a higher pavement thickness. So always when the load criteria is exceeding, the thickness should be increased. That's why trial thicknesses are made, and then ultimately the final thickness is to be found out so that the stress developed due to the load application, both inclusive of wheel load stress and temperature stress, will become well within the permissible values as stated by IRC. The factor of safety of the trial thickness of the pavement is worked out by taking the ratio of flexural strength to the flexural stresses. Design life should also be estimated. If the stress ratio exceeding 0.44 due to the higher loading are noted, then the fatigue analysis is carried out based on the number of repetitions during the design life. If the assumed thickness is failed, the next trial is made after suitably revising the thickness. The total of the edge load stress due to the heaviest load and the edge warping stress on summer midday is calculated. If the total thickness is less than the flexural strength of CC, the design is accepted. Otherwise, the thickness is further revised until the highest possible total stress value does not exceed. Okay? Thank you. That means we have completed both 5th A and B. Okay? In fact, there is no B part. Combined together, A and B, 5th unit. So thereby 6th unit is already over earlier to this. Now we are completing 5th unit also. Thereby all 6 units are effectively to the best possible extent we could complete. And we have conducted all 6 tests on all units, 1 test each. And you people have studied and prepared well and attended and fetched good marks also. Please submit the journal well in time so that assessment of term work is also being done. So in order to say or in order to credit the marks to individual students, it may not quite possible for us to see everybody should get same marks. That's why criteria: late submission, little late submission, 2 late submissions will be given less marks compared to the one who has been submitting the term works well in time, apart from assignments. Total around 9 to 10 assignments have been given. Until unless all the 10 assignments you are completing it, you will not get good marks in term work. Okay? Of course, if 50% of the assignment is submitted, all journals well intact they have submitted, they will get at least 25 to 30. 25 to 30, not doubt. No, not less than 25. The one who has not at all submitted anything and he is sending everything at the nth moment, simply passing mark will be given. That is 20 marks out of 50. Please do not think negatively. Take it everything sportively. You yourself put the question to your conscience. Have I submitted the assignments time to time? Have I written the journal neatly? Have I written the figure? Or have I simply scanned the figure from our friend and then sent to teacher? You put questions, you will get the answer. Then even though you get overall at the end of the day, out of 50 marks, if you are getting 20 marks on your mark sheet, you will not feel sad, because your conscience will not allow you to become sad because you have not performed well throughout the semester. Am I right? With that, I conclude this subject. Expect good cooperation. So far expected, and it was given by you. Thank you very much, especially Miss Harshada Wag and Tipaile sir. I would like to acknowledge and extend my wholehearted thanks for providing me all the PPTs throughout this semester. They have helped me a lot, and our colleague of civil department really helped me at each and every stage during lockdown period, since lockdown period till today, so that I could deliver the lecture so happily and confidently through these PPTs on online teaching. Thank you very much. God bless you all, including us, because Almighty is equally likely for all human beings, whether he is a teacher, whether he is director, whether he is management personalities or Prime Minister. Almighty God is same for all. He has to bless all the people. And let us pray God that this COVID-19 pandemic disease should go away from each and every human being on the earth who is living. Okay, thank you once again. Goodbye for this semester. However, our relation will exist. Relationship will establish till the years to come, days to come, weeks to come, months to come. Okay, thank you. Have a nice day. Please study well and fetch good marks if at all exam is held. If not, also enrich your knowledge. Okay, thank you. Have a nice day.